Okay, in this video I'm going to look at some applications of the remainder theorem and factor theorem by looking at some problems from college algebra. Let's look at example number 1. Find the remainder if f of x is divided by two parts, a, x minus 5, and b, x plus 4. And it wants us to find the remainder. So what I'm going to do is look at the remainder theorem. The remainder theorem states if the f be a polynomial function, if f of x is divided by x minus c, then the remainder is f of c. So that basically tells me then that if I want to know the remainder when polynomial f of x is divided by x minus 5, so this would be x minus c, so the 5 would be c. According to the theorem, I would simply put a 5 where the x is and compute that out, and whatever number I got, that would be the remainder. So you could do this manually, 5 to the 4th, then here 5 to the 3rd times the negative 3, 5 times 2, and then minus 4. But I'm going to use the calculator, and there's various ways to do it using the calculator. One way is to look at the graph. So let's enter the function x to the 4th minus 3x to the 3rd plus 2x minus 4. Okay, let's hit graph. So here's what I'm going to do. I'm going to go to second, and then I'm accessing the calculate menu. So hit the trace key here, and I want value number 1. So just hit 1 or hit enter, and then just enter the value. So in this case, c would be 5. So I put a 5 right there, and then hit enter, and I get the value of the function right here, 256. So the answer to part A, if I were to divide this polynomial by x minus 5, the remainder would be 256. Okay, now to get the answer to the second part, okay, what's the remainder if I divide by x plus 4? Well, in this case, remember the remainder theorem has an x minus c, so I'd have to write this with a minus, so this would have to be x minus a negative 4. So same thing. Go to second, calculate, hit enter, and then enter the negative 4. Okay, and then hit enter, and I get 436. 436. And there's other ways to get these answers on the calculator. This is just one way. If you've seen some of my other videos, you'll know how to do that. But that's one way to do it. Okay, let's go back to the graph and then clear. Okay. Now for the next one, this one states find the zeros of f of x equal to this expression here. Find the zeros. So the zeros, remember, are associated with the x-intercepts. So all we have to do really is find the x-intercepts, and we have the zeros. So again, we're going to enter this graph. X to the 3rd plus 8x to the 2nd plus 11x minus 20. Okay, let's hit graph. Okay, so first keep in mind that this is 3rd degree because of the x to the 3rd. This is 3rd degree. So the most zeros you can expect is 3. Okay, you don't have to have 3, but that's the most you can expect. So notice over here in the graph crosses the x-axis here, here, and here. So this one is going to have three unique zeros. So one way to do it is go to the table. Let's get second. And let's look at the table. If the zeros turn out to be whole numbers or integers, then we could easily just scroll through the table. Okay, so notice here, -5, 0. That would be a x-intercept. -4, 0. That would be another x-intercept. So that means that the first components of the x-intercepts are your zeros, because those are the numbers that make the function 0. So one 0 is -5, the other one is -4. So that gives us 2 right there. Okay, now we need one more. So let's go. If you remember the graph, there was one intercept on the right side of the x-axis, so we should have a positive 0. And there it is. 1, 0. Okay, so the zeros for that one then are 1, -4, and -5. Okay, let's clear this one. Number 3, same thing. Find the zeros of f of x. Find the zeros of f of x equal to this expression here. So okay, let's enter that. 6x to the third power minus 19x to the second power plus 8x plus 5. Okay, let's hit graph. Now this is again third degree here. So the most number of zeros I can expect would be 3 or less, but no more than 3. So let's hit graph. Okay, so you can see I have a 0 here, I have a 0 there, I have a 0 right there, because those are the intercepts. Okay, so let's look at the graph. Or I should say the table. Okay, so let's look at the negative side there. And remember, you have a 0 when the y component is 0. So I scrolled through that. And doesn't appear to have any there. Let's go to the positive side. Okay, so here's 1, 0. 1, 0. So that is one intercept. So 1 is a 0. Okay, let's look at the graph. Now let's go to see if we have anything else over here. And if we scroll through, you can see there's no other intercepts, and that could be because the zeros turn out to be fractions. So they're not going to be here. They're just going to give you the integer values here. So let's look at the graph again. And the one, probably this one right here. So let's try to find this value right here. And I'm going to go to second, hit the trace key, which means I'm accessing the calculate menu. Okay, so here's what I'm going to do. I'm going to enter 2. So I'm going to try to get the zeros this way. Okay. So in another video I did something similar to this. We need a left bound. Okay, so we're looking for this one right here. I put the cursor there on the left and then I hit enter. Now they want a right bound, so go past that. So hit the arrow key over here. Okay, just go past it and then hit enter. And then for the guess, you can just ignore it and just hit enter again. Okay, so notice y equals 0 and x is equal to -0.33333. Okay. You should be able to recognize that as a -1/3. That's negative 1/3. Okay. So negative 1/3 and 1 so far are the zeros of that polynomial. Okay, we're assuming this is 1 here, so let's try to get this one here again by doing second trace, accessing the calculate menu, hit 2. Okay, so now I want to move the cursor all the way to about here somewhere. So hit the arrow key here. Okay, so it's right there. So let's hit enter. That's now it's a right bound. So hit it one time just to go up. Hit enter. Ignore the guess. Once a guess here. Just hit enter again. And it tells me, look, x equal 2.5, y equal to 0. Okay, so 2.5 and 0 is an x-intercept. So 2.5 is the 0 of that function, which is 5/2. So you convert that to a fraction. 2.5 is 5/2. So the zeros for this polynomial are 1, negative 1/3, and 5/2. Let's clear this. Okay, let's look at the next one. Number 4. Is x minus 3 a factor of this polynomial right here? Okay, so again, there's many ways to do this. You could divide, you could use long division, divide this out, and if the remainder is 0, then you would say yes, it is a factor. If the remainder is anything else but 0, then you say no. You could use synthetic division, and it works the same way. If the remainder is 0, it's a factor. If not, it is not a factor. Factor theorem is one I use here. Factor theorem states, let f be a polynomial, then x minus c is a factor of f of x if and only if f of c is equal to 0. So that means that the easiest way to determine whether this is a factor of this polynomial, in this case it's x minus c, so c would be 3. So all I have to do then, if you want to do it manually, you would put 3 right there with the x. 3 to the 4th, and here 3 to the 3rd times minus 8, 3 to the 2nd times 7, 3 times negative 8 plus 21. Compute that out, and if that comes out to 0, then it is. Okay. Or you could do it in the calculator. Now, I could do this the same way that I did the earlier problem. I could graph it. I could graph this polynomial right here, enter in the graph, and then use the value method that I did a while ago. But just to show you a different way, I'm going to do it like this. So in this case, x is 3. So I'm going to say over here, let me go to the home screen. So let's hit 3, and then store, hit the store key right here, and then x, and then hit enter. That means if you type any expression that has an x and then hit enter, then it's going to evaluate that expression at 3. Okay, so that's what I want. I want to know what is the value of this expression at 3. So I just type it in and say x to the 4th minus 8x to the 3rd plus 7 x to the 2nd minus 8 x plus 21. Let me double check. X to the 4th minus 8x to the 3rd plus 7x squared minus 8x plus 21. So hit enter, and I get a negative 75. Okay, so I did not get 0. So that means that x minus 3 is not a factor. Okay. If this had come out to 0, then it would be a factor. So again, there's 3-4 different ways you could work this problem. Okay, that concludes this video. Be back later with another video. Hope this helps, and if it does, please subscribe. We'll see you next time.